Welcome back to our YouTube channel. Today we are going to discuss about an interesting project which is optimization in solar power generation, which is a data analysis project. So here we are going to discuss about the business problem, what is the business objective and constraint, how we have solved this business problem and what are the dashboards we have come up with. So these are the things we are going to discuss in today's session. Let me start with the business problem. So here we have followed some methodology called CRISPR-Matthew. So from that, the first step, which is business understanding and data understanding. So after that, we have prepared some project architecture. What is the flow from end to end? Okay, from the starting of the project to till end regarding the data analysis, dashboard creation. So we have prepared here. So after that, we have prepared some EDA, data analysis, data preparation, and visualizations in various BI tools. The first one, before entering into the business problem, let me tell you some of the basic concept of solar power. So you already know about it. So how the solar power is producing, how the electricity is generating in the solar form. So here it will take it from the sunlight. Okay, it's not a sun. It's not about the heat. It's all about the sunlight. How much sunlight it's reflecting on that solar thing panel, that much amount of current will produce it. Okay, in case if there is much amount of heat are producing based on the sunlight means it will affect the solar power generation also. So from that sunlight it is producing solar power based on that solar panel, and then that solar power are transferring to a inverters, or we can say a charge controller. So in this inverter we are having some conversion, you already know about it. That is AC current to DC current or DC current to AC current. We are having multiple inverters. So here we are having a DC to AC, that is direct current to alternate current. So here we are having a system called SCADA. Okay, so SCADA, which is used to monitoring the power flow. Okay, so how much power is producing, how much flow we are having, what is the loss, each and everything it is monitoring based on one system called SCADA. Okay, so then that AC current is going to the transformer, and from the transformer, it is moving to the industrial uses or home based uses or some uh, that is the grid based things. So today we are going to discuss about the business problem, which is our one of the leading clients facing a frequent fluctuation in that solar power energy. So output based on some variable environmental condition or some system efficiency. So this was limiting the optimal solar power generation. So here, what is our business objective in the sense? We are going to maximize the power production as well as we are going to maximize the system performance. So from this, our business constraints, we need to minimize the operational cost. So this is all about the data analysis project. So here we are focusing on two success criteria. One is business success criteria. Another one is economic success criteria. So here we are focusing on that business point of view, achieving 20 to 30 percentage of the increasing in profit. And second one, economic success criteria, we are going to increase the revenue by 30 percentage and also reducing the operational cost through improving the solar power generation efficiency. So this is all about the business understanding. So now we are going into the data understanding. So before data understanding, let me share you some technical stuff. So what are the programming languages we have used? So what are the EDA techniques we have used? What are the data storage and management? What are the visualization tools we have used here? So these are the things, let me tell you first. So coming to this programming language, we have used Python programming language and then SQL, structured query language. In Python, we are having enriched inbuilt libraries. So like from that inbuilt libraries, we have used Panda, NumPy, Matplotlib, and Seaborn. And for SQL connection, that is database connectivity, we have used SQL Alchemy and then PyMySQL. So what are the EDA techniques we have used to analyze the data? That is exploratory data analysis we have used here. Means first one, statistical analysis. First moment business decision, second moment business decision, third moment, fourth moment. From each and every state, we have collected the statistical insights as well as business insights also. And also we have performed some various graphical representation using univariate graphical representation, bivariate, and then multivariate. So from this, we have identified the correlation between the columns and also trends and outliers. And then for data storage, here we have used the database called MySQL. So based on that, we have stored all the data and we perform some calculation in MySQL also. And finally, for the data analysis and visualization, we have used the business intelligence tools like Power BI, Tableau, and then Google Looker Studio, that is GLS. So from the Power BI, we have came up with a multiple interactive reports as well as dashboards also. So now this is the architecture. That means we have to collect the data from the business user. After that, we have to store it in a data store. So from that data store, we have to collect the raw data. We need to do some EDA analysis as well as we have to get to know some statistical insights and some business insights. From that, we have performed the data pre-processing because we have identified so much of errors in that. And then we got the clean data. From the clean data, we have prepared the dashboard. Based on this dashboard, we have selected multiple insights for the business point of view, and we have shared that with the clients. So this is the overall architecture of our project. So here coming back to this data understanding, it's a secondary data source because we have collected the data directly from the client side, and this data as the record 13,000, that is 1,31,039 records are extracted and the data format which is in the Excel form. Okay, so here we got two different data sets. One is for the system point of view, another one is for the weather point of view because here environmental condition playing a vital role. So we got the data which is regarding to the weather format also. And we have integrated both the data, that is system data as well as weather data. And from that we have performed the analysis. So what are the various columns we are having after combining both the data set? Totally 9 columns are there. From the weather base, we are having date time and then GII, that is global inclined irradiance. That is how much sunlight are passing into that particular area, and from that area, how much current are producing. And then module temperature. So module is nothing but the solar panel. For each and every panel, there will be certain temperature is there. So it is going to be recorded in the SCADA system. So that we have collected. And then rain. So if I'm having rain means that will be like a one of the variable condition. That is if I'm having cloudy, so that will affect the sunlight. Based on that sunlight, it won't produce the power. So the rain data we have collected and then ambient temperature. So ambient temperature is nothing but surrounding temperature. Module in the sense solar panel temperature. Ambient temperature is nothing but the surrounding temperature. So based on the surrounding temperature, here sunlight and heat playing a vital role. If sunlight is high, the protection will be high. In case along with that sunlight, if I'm having heat is also there, means that will reduce the power generation because of the losses will be there. So apart from these things, we have collected 4 inverter data here. From unit 1, we are having 2 inverters. So inverter 1 power column and inverter 2 power column. And in unit 2, again we are having inverter 1 power column and then inverter 2 power column. So based on this, we have prepared the data dictionary. So it's all about a datetime column is common for both the table. Based on that, we have combined it and it's become a single table. So after that, we have performed a analysis. So this is the exploratory data analysis, mean, median, mode variance, standard deviation, range, skewness, kurtosis. So all the 4 business moment decisions are there. So from this, we have came up with statistical insights. That is mean and median are very close with the distribution in inverter 1, in inverter 2, Okay, that is unit 1 inverter 1 and unit 2 inverter 2. After that, we are having some deviated from mean, which means the high variance we are having in the data set. So likewise, we have prepared some statistical insights along with that business insights also. Comparing all the four inverter that is unit 1, inverter 1, unit 2, inverter 2 are performing very well. And that is in unit 1, inverter 2, unit 2, inverter 1 generates more output comparing with other inverters. So here we are having some leptocurticistic, that is positive curtices we found. So from this we can say we are having some deviation in the data. And then so we have stored in the database because we have collected directly from the client source, and then we have stored that raw data into the database, which is MySQL. And for the manipulations, data manipulations, we have used Pandas. For database connectivity, we have used SQL Alchemy and URL lib for special characters. And finally, so we did some pre-processing techniques and exploratory data analysis in SQL also. Along with Python, in SQL, we did this calculations. And finally, regarding the duplicates, so we got some duplicate, and based on the combination, we have removed the duplicates, and finally we got uh, clean data. From that clean data, we have prepared the dashboard here. So from this, we can identify what is the total power output, what is the global incline, total global inclined irradiance, and for each and every month, because here we have collected the data for last 3 months, January, February, March, and from that we have prepared this dashboard. So this is the dashboard which is based on Power BI. So here we are having two different reports, and also we have prepared the dashboard using Tableau because we have to explore various business intelligence tools. So along with Power BI, we have prepared the dashboards and reports in Tableau also. And finally, the Google cloud-based BI tool, which is Google Looker Studio, we have explored that also. And from this, we have came up with dashboard optimization in solar power generation. So it's all about based on the last 3 months data regarding a solar inverters and how that particular powers are producing. So thank you so much for your time, and we will meet in the next project explanation session. Thank you, friends.